Hey everyone, welcome back to MLWorks. In this video, we'll be discussing about computer vision and we'll primarily focus on three computer vision tasks. That is, we'll first talk about detection and annotation of objects in an image, and then we'll discuss about video analysis where we try to detect, annotate, track and trace an object in a video. And then we'll also do something called as key point tracing or tracking in video analysis. So we'll also talk about three different libraries that we'll be using across this video or for this tutorial. So first is Supervision, where we try to annotate all the predictions that is generated by the models. So we'll use Supervision for that. And then we have Inference and Ultralytics, so where we'll be using those as a model provider, which has many lightweight computer vision models. Especially we'll be using YOLO, and we'll be using those models for detection and annotation and tracking the objects in a video and image. Now these tasks, right? Basically all these tasks that we are talking about, they have like wide application in terms of real time. For example, you can use it across autonomous driving or monitoring patients or surveillance camera or inventory management. So all these have something called as detecting an object, a person or an action. So all these things related can be captured by computer vision, and especially these libraries are capable of doing that. So with that, let's get started with the tutorial, where the first step is to install the package, and which is very simple in this case. You just have to install all these three different pip install you have to do and get started. So what I have done is I have taken all these three packages and created a virtual environment, and I'm using that environment in my Jupyter notebook. Now I mentioned earlier, so we'll be using model, which is the YOLO, and here we'll be using specifically YOLO 8N, which is a nano version of the YOLO 8 model, which is faster, lightweight, and it is for real-time inference. It could be very good, and when you don't have like a lot of resources, for instance, I'm running it on a GPU machine, but even if you don't have GPU machine, you will be able to run these models. Because I have seen the model size, it is around, some models are around less than 10 MB, some of them are less than 100 MB. Okay, so it should be you should be able to run it anywhere. So with that understanding, let us import the packages. First we'll be importing OpenCV, which is CV2, and then Supervision, which is for annotating the predictions, and then Inference for downloading the model. This is for plotting the whatever you want to plot, image or video, whatever. Okay, so let us import those, and then let us look at the image that we want to work with. This is the image that we want to identify the object in, and we are importing it or reading it through OpenCV, and then we are turning it into RGB format, because by default it will be in BGR format, and then we are just showing the image as shown here. So let me clear this first for once and run it again. Okay, this is the image, and now what we have to do is we have to do simple get model, give the model ID. This is 640, refers to the resolution of the image which it has been trained on, and then this will download the model, and then we do inference on top of the image and get the list of results that we have, right? That will be stored in index 0. So we are picking it up and storing it in results variable. Now we are transforming those results into detections with the help of Supervision library, and we are doing something called as sv.detections from inference. So since we are doing the prediction with the help of inference library, so we are doing from inference. If it is not from inference, okay, let me just show this one, detections dot from. So you can see there are different libraries which are capable of doing the prediction. Okay, it could be detectron2, deep sparse, inference, ECOCR, MM detection, NCN, paddle determination, whatever, SAM, TensorFlow. So many other libraries are supported by SV. Okay, so here we are just using inference. So we do dot from inference and we pass in the results and get our detections. So next what we do, with the help of the detections, it contains a lot of information. The things that we are interested is the class name, and we are interested in the confidence score of the detection. So what we do is we iterate through those two features. In this case, it is class name and the confidence. We iterate them and try to create a list of all the detections that has happened. So we term it as labels. Now let me run this and let me code here what is labels. So you will see it has detected 2 trucks. What is the corresponding confidence score and for both truck and car. Okay. Now, so we have our detections, we have our labels, we have our image. Now what we want to do is we want to annotate our image with annotations. So for that, what we'll do is we'll take in sv.box annotator to create box around our objects, and then we'll take in sv.label annotator for adding the label to each of those objects. Okay, so we define those 2 annotators, and next we annotate those images. Now just for the sake of understanding, if you don't put labels here, it will directly use the detections and it will try to annotate the object. Okay, annotate the object in the image. So since we have given a custom labels and which we got it from here and here, okay, so we'll be plotting those labels on top of the images. We'll be seeing that in a second. So we have annotated the images. Now we want to see the annotated image. So let me run this cell again. So here if you see, you will see all the bounding boxes that is coming up, okay, for each of the object, and then you can also see the label along with the confidence score and the class name. Okay, so if I don't give this custom label, what will happen is it will just detect truck and it won't show you the confidence score. This is with respect to just detection of an object and adding an annotation to it. Now what we'll do is we'll talk about next level of object detection, which is segmentation, where we want to segment each of those objects at the pixel level. So what we do is, for this we want to download a segmentation model using get model, and then we again load the image, do the inference and get the detections. And instead of doing box annotation, which we normally did earlier, we'll be doing mask annotation. Mask is nothing but it will be applying over the object, whatever the annotation it has to apply. And the label aspect, okay, for the label annotator, where you want to show your label for the specific object. So here we are putting it on the center of mask. It will be on the center of that specific object. Now with that, we start annotation. So here we have mask annotator dot annotate. We send the image and also the detection that we got for that image. Similarly, here we have label annotator. So this will do the mask annotation and this will do the label annotation. So let me run this. So it has done that. Now let us view the annotated image, which is with the help of this specific code. So you will notice at the pixel level, it managed to identify the truck, and at the center of those specific object, it gave that specific label. So it has detected around 2 trucks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 cars. So I'm not sure about these one. Let me see if it is correct. Yeah, so these are correct. Yep. So what we have done till now, okay, we have taken image, we have detected the object, we have annotated the object, we also did segmentation of the object, and we also added labels, custom labels to that specific object that got detected. Now what we'll do is we'll move on to the next task, which is video analysis, and where we'll be tracking again people in the video and detect them, track them, annotate them. Okay, so let's get started. So here what we'll do is, instead of just for a variation, we'll be using Ultralytics. Instead of Inference, you can use this also to download the model. Okay, we import YOLO from Ultralytics and get the specific model that we want to use. Again, this is also a nano version of YOLO 8. Now here if you see, we also import NumPy and Supervision for annotation. And so what we do is, first we download the model and then we create an object for box annotation. So we want to put box on top of all the objects that are moving inside the video. And what we do is, before jumping onto the callback, okay, we want to do something called as sv.process video, where we have a video of generally people walking around. Let me show that video first. This is the video, and where we have so many people walking, and there are different objects also present like bags and especially bags. Now what we'll do is, I'll just close this video for now and go back to Visual Studio Code. So what we do is, in sv.process video, we take in this video which we saw now, and we'll be calling this function, which is the callback function. And what this callback function will do is, it will iterate through each of the frames from the video, and it will apply the model, and it will try to detect all the people in that specific frame. Okay, once that is done, those detections are then passed to annotation for annotation, and that will create bounding box around those specific detection. That's what is happening in callback. Now at the end, once this call function is called, it has to be stored as a result. So what we do is, we pass target path and the file name is result.mp4. So let me run this. So this takes some time, because if I am not sure how long is the video, so it is around 14 seconds video, and there will be around per second there are 30 frames. So it takes through each frame and it takes everyone, and it tries to annotate with the box annotator. So close this. It's already done. So if you see here, this file is there. Let me open it. So now the model has detected all the people, and it is frame by frame. If you see, it is jittering, right? In the between, it is like going up and down. It is frame by frame it is happening. So it is detecting those specific object again and again, annotating them. So let's get back to this one, track object, which is using byte track. So what we do is, when we are trying to track someone while in the video, what you do is assign a unique ID to that specific object. So we'll be using a byte track to do that, and it will be following that specific IDs, following along the same object throughout the video. Now if you see here, for that what we have to do is, we just have to initialize byte track from SV, and that will be our tracker. And the same thing, dot process video, we pass in the source path and target path and callback function. And inside the callback function, we iterate through each of those frames, get the detection or the result, and turn them into detections with the help of this SV detections. And then we add those detections to the tracker, and we keep updating the detections. Okay, so it is like continuously monitoring that specific object. And then we also add annotator on top of it, which is the box. Okay, so if you see here, it is around 37 people are there. Okay, so if you see, it is also detecting incorrectly certain times, right? It is simultaneously running, and it is able to see the 37 people, 2 birds, and 4.8 millisecond. Okay, so it is, as the videos are moving one frame to another frame, it keeps detecting people, and some are misclassified as birds. So it is stored as tracking detected objects. So this is the video name that we storing it as, tracking detected objects. So yeah, it is tracking all these objects that are getting detected. So you will also notice some of them will be detected as, so if you see, there is some multiple detections are happening like bags, and those are happening. So this is with respect to tracking those objects that got detected. Now what we want to do is, we want to label those detected objects. With the help of byte track, we generated the track ID. Now with the help of the track ID, we can annotate each of those objects that got detected. So let's see how to do that. So first, as usual, we want to download the model. Okay, it's already downloaded. We have to initialize byte track. This will give you tracking ID, and then we have annotator for box to generate a box around the object, and we want to add label to it. So we have label annotator, and this is our process video where we have source and target path and a callback to the callback function. So here again, as usual, what we have to do is, since we are using Ultralytics for downloading the model, we are using that for detection here, SV detections from Ultralytics. And here, this is where we do the inference, and then we will be tracking it. And then what we do is, we generate the labels like custom labels. And while you are trying to annotate, First we annotate, the box annotation is done, and then on top of it we are also doing label annotation. If you see here, you have to follow the exact hierarchy of things here. First you want to do the box annotation, you get annotated frame. Now annotated frame is passed to the label annotation. So you will be taking those annotated frame, and then we'll have the detection and the labels, and this will on top of the box annotation you are doing this also, like label annotation. So let me run this, and it is stored as annotate tracked object. Let me go to this file. So where is this? This is where it is. So it is running. Let me see if it is still running. Yeah, it is still running. Let's see why. Yeah, it is done now. Here we have annotated tracked object. So if you see here now what we have, right? So for each of that object that got detected, we are adding the label, okay, which is the person. We're also adding the tracking ID we have created for each of those, which are present for each of those objects that got detected. For example, here it is 3, it is 25, and if you see, this is getting mislabeled also. This is 25 as bird, and this is 11 as bird. Okay, so this is also not accurate enough, but still it works. So it has majority of the results are good. Now let me close this, move on to the next step. We saw people are moving in this video, and we want to understand that path traced through. We want to understand how they are moving. Okay, so for that what we have is something called as trace annotator. So it involves overlaying the historical path of the detected objects. This feature, powered by sv.trace annotator, allows for visualizing the trajectories of the object. So if somebody is moving in a specific direction, you can understand that what will be the next step. So it will be able to get the trajectory of that specific object. So we'll do that with the help of trace annotator. A bunch of steps remains the same: downloading the model, byte track for getting the tracking ID, creating the box, adding the label, and then now trace annotator to getting the detection of flow. So these are like defined here. Now what we do is, while in the callback function we do inference, then getting the detections, we are updating the tracker with the detections, and then we create our labels. Now along with box annotator and label annotator, we just add trace annotator. So here we pass the annotated frame, and then we trace annotator is applied on top of it. So this is called trace annotated. So let me run this. So you will keep seeing, right, for every frame how the model is detecting. You will see there are 3 birds. In some cases, in some frame it detected 2 birds. So let me just also show you the model. Right here we have that model, which is YOLO 8N PT, which is around 6.5 MB, and there is another model which we'll use, which is YOLO 8M-post PT, which is the PyTorch sensor. We'll be using that as well. Now, so it has done the inference. Let's go to annotated, trace annotated. Yeah, so you will see the tracing, right? Behind every object there is a trace happening. You will see the trace, how in the direction it is going along with the object. So it is detecting handbag, and it is also detecting their flow as well. So till now what we have seen is we have applied annotation and detection in images, and then we moved on to the video. Now what we'll do is we'll do video key point tracking, and we'll be downloading a data from this specific library itself, which is supervision.assets, and whatever the video you want to download, you can download from here. And since this is key point tracking, it has a different kind of annotation, which is edge and vertex annotator. It is similar, the steps are quite similar. So first you download the model, then define the annotations, which is edge and vertex annotator in this case, and then again do sv.process video, source and destination path, and then callback. The callback is again going back to this function where you frame by frame you try to detect the object. In this case it could be the video of a person skiing, and then what we do is we do sv.keypoints from Ultralytics and get the results that we get from the model. We turn that into key points, and then we annotate with the help of edge annotator and vertex annotator. So let me run this. Let's understand what is the video, right? Skiing, what is the skiing video is. Yeah, this is the video. and we'll be specifically interested in this person who is keying. We'll be interested in identifying the key point for this specific person. So let me go to the Visual Studio. Yeah, it has done, and the video is called as key point. So let me open that. Now it has detected key points in that specific person, and we used a specific model for that, which was, if I go back to this one, so here we have pose. The model which is like pose estimation is the model we use for this specific purpose, and this is what the video looks like after key point detection. Okay, here we don't have any box annotation till now. Okay, we don't have anything else. We just have key points getting detected in a person. Now let me close this. So we have done with edge and vertex annotator for key point detection. Now what we do is we use box annotation, and it will try to create a bounding box around the object. So what we do is, again, we download the model. Along with these two annotators, we bring in box annotator, and the only change is we do inference, get those key points from the results and turn them into detections. Now since we are doing box annotation, we want to turn them into detections for the help of key points dot detection as detections. So once that detection is there, we can just directly go ahead in box annotator and use those detections. So let me run this as well, and let's wait for that video to come up. So in this case, it is key point hyphen detections. Okay, so let's wait. Oh, here we have our video, which is this one, key point detection. Now along with the key points, we also have box annotation around the specific object. And the next step, what we do is, along with box annotation, we do trace annotation, which is as simple as what we have done earlier. Only thing is, we want to trace that specific object. We want to have a tracker ID, so we want to use byte track for that first, and then use that tracker to create a trace, okay, of every object that is present. So as usual, we have these three annotators. Along with that, we added two annotators now. One is byte track and a trace annotator. Now as part of this callback function, we do inference, get the results and turn them into key points, and then turn those key points into as detections, such that we can create bounding box across those objects. And then what we do is, we have this tracker and we update with detections. So we add the detections that got created here. Now when it comes to annotation, okay, first we have edge annotation, vertex annotation, and then boxed annotation, now trace annotation. Okay, this will identify the flow in which the person or the object is moving. So everything takes some amount of time. So this time it is, the file name is key point detection trace. Key point detection trace. Yeah, this is the one file. Yeah, so let me click this. Now if you see, right, this is the historical path that was taken by the object, and it is able to track that specific object along that specific line. Okay, this is the way the object is moving. The frames. So we are at the end of the video. Okay, we have done a bunch of stuff. One is, we have looked into 3 libraries and we try to complete 3 different tasks. First and foremost is, on top of images, we try to detect and annotate. Next, we used video and try to apply detection, annotation, tracing and tracking on objects in the video. And then we started with key point trace tracking. Okay, so with that, I'll be concluding this video. Thank you for watching.